Let's look at the bisection method. This method allows us to approximate what x value makes my function 0. It works based on the intermediate value theorem, which tells us that the x value that makes my function 0 must be between an x value that makes it negative and an x value that makes it positive, which is a really simple idea. Let's take a look at an example. Here we have a profit function that tells me my profit in millions of dollars based on how many tons of coffee I sell. My boss wants to know when I will break even and have a profit of $0. He wants me to consider the interval from 0 tons sold to 4 tons of coffee sold. This method has 3 steps. The first is to find the midpoint of the interval we're given. All you have to do is add up the endpoints and divide them by 2. Next, we're going to test our function at that midpoint and at the endpoints. If we get 0 for any of the points, then we've found the 0 of the function. If when we test these points, our function is really close to 0, within some margin of error that's in the problem, then we're good to go. Or if our interval is narrow enough, the midpoint is going to be the answer. Lastly, if when we plug in these points we get a positive number or a negative number, we're going to have to pick a new interval that's going to be smaller. This interval is going to have 2 x values whose y values have opposite signs, one positive and one negative. Once we pick that new interval, we're going to repeat the first 2 steps and then just keep on going through until we find our 0. So let's look at an example. My profit function is y equals 2x minus 6, and we're going to approximate when y equals 0 on the interval from 0 to 4. So first I just make a table. First column is my interval, next one is my midpoint, and the last one is my endpoints. So let's start with the interval we're given, 0 to 4. Our midpoint is 2. We plug in 2, we get negative 2, and we test our endpoints. So when we tried our midpoint, we didn't get 0. So now we need to pick a smaller interval that ranges from a positive number to a negative number. As we can see, when x equals 2, we have a negative number, and when x equals 4, we have a positive number. So now we can try from 2 to 4, which is a smaller interval. So now we have 2 to 4. Let's find the midpoint. X equals 3 is the midpoint. When we plug it in, we get 0. So that was a lucky break. We found the 0 of our function. Let's look at a trickier example. Here, my function is y equals x to the 5th plus x to the 3rd plus x squared minus 1. We want to approximate when y equals 0 on the interval from 0 to 1 with an error of less than 1/16. Now that we have a margin of error, before we start, let's just figure out how many times we have to go through with the method before we're going to get our right answer. The way to do that is very simple. Basically, we're going to set up this expression b minus a over 2 to the n equals e, where e is the error that we're given, b is the far right endpoint of our interval, a is the far left endpoint of my interval, and n is the number of times we have to do the method. So we solve for n. Let's look at this example. 1 minus 0 over 2 to the n equals 1/16. We can rearrange that to get 2 to the n equals 16. Solve for n using logarithms, we get n equals 4. So we know we're going to have to use the bisection method 4 times before we're going to be within our margin of error. Now let's use the method. We're going to set up the table again, and we're going to start with our biggest interval from 0 to 1. The midpoint is x equals 0.5. When I plug it in, I get a negative number. So now we need a new interval. I'm going to go from 0.5 to 1 because the y values go from negative to positive, but it's smaller than my original interval. Now we're going to find the midpoint again. That gives me 3/4. Plug it in, I get a positive number. So now I'm going to have to go from 1/2 to 3/4 so that my y goes from negative to positive. It'll go from negative 0.59 to positive 0.22. So let's try that new interval. The midpoint of that interval is 5/8. We plug that in, we get a negative number. So now if I want my interval to go from negative to positive, I'm going to have to go from 5/8 to 3/4, which will be an even smaller interval. Now this is our 4th iteration of the method, so we know at this point the midpoint we get is going to be within our margin of error. The midpoint of this interval is 11/16. When I plug it in, it's pretty close to 0, and so we're just going to approximate the 0 of this function as x equals 11/16. So that's how you use the bisection method to evaluate the zero of a function within a margin of error.